For lesson 6, we're going to solve absolute value inequalities. So we'll do that first, then we'll solve multi-step absolute value inequalities, and then we'll solve a real-world problem. There will be two different types of absolute value inequalities we're going to solve today. When the absolute value is less than a certain number or value. So for example, we have the absolute value of 3x plus 4 is less than 10. Knowing what we know about absolute values, that means that this 3x plus 4 must be greater than negative 10, because if it was negative 11, that would turn into positive 11 if you do the absolute value. But it also must be less than 10, because if it was positive 12 or 13, that would also turn into higher than 10. So that's the kind of equation we need to write from here. Then you could solve for both by subtracting 4 from both sides of the inequalities and then dividing by 3, and then you get your answer. You'll notice that this turns into an and inequality, and that's always the case. Whenever you have an absolute value less than a number, it's an and inequality. It's just the opposite for the greater than ones. You want the absolute value for these to be either greater than 6, like 7 or 8, or smaller than negative 6, like negative 7 or negative 8. Both of those would turn into bigger numbers than 6. So here we would have 3x minus 12 needs to be greater than 6, and 3x minus 12 needs to be less than negative 6, so like negative 7 or negative 8. Then you can solve from there, and it turns into an or inequality. 3x needs to be greater than or equal to 18, or 3x needs to be less than or equal to positive 6. So we have the absolute value of x needs to be greater than or equal to positive 6. So for the greater than one, it's an or inequality. X needs to be greater than or equal to positive 6 to create a higher absolute value, or it also needs to be less than negative 6 because that would create a higher absolute value than 6 as well. So if I'm going to plot these out, I'll start at 0 and count by 3s. I would do closed circles for both 6's because they're both equal to. And then I would have greater than positive 6, and I would have less than negative 6. So it's an or. And then anything along these lines would be okay, but all of these numbers would create a smaller absolute value than 6. Now I have the absolute value of x is less than or equal to 0.5. Remember, a less than inequality would create an and inequality. So I know that x needs to be between negative 0.5 and then also positive 0.5. If it was any smaller than negative 0.5, like negative 0.6, that would be a bigger absolute value. If it was any bigger than this, like 1 or 2, it would be a bigger absolute value too. And it's supposed to be smaller. So we could plot these points out. Let's do a 0 for our center. Count by 0.5. We'll do closed circles at the 0.5s. And then this arrow is going this way because x is bigger than it. And then this arrow is going this way because x is smaller than this. So here would be where our answer would be between these 2 points. So let's solve these compound ones then. We have x minus 5 is greater than 7. Remember, the greater than ones have a or inequality. So therefore x minus 5 would have to be greater than positive 7 because the absolute value needs to be greater. Or the x minus 5 needs to be less than the negative 7 because negative 8 or negative 9 would give you a greater absolute value too. So if we're going to solve for both of these, we could add 5 to both. And that would give us a couple answers. We'd have x is greater than 12, and then x is less than negative 2. So if we have zeros and we count by 5s here, we could plot these points that x is greater than 12, so we'd have a open circle, and then an arrow going that way, and then x is less than negative 2, so we have an open circle at negative 2, and an arrow going the other way. So the x values have to be either smaller than this or greater than this to produce a larger absolute value than 7. We have the absolute value of negative 4x minus 5 plus 3 is less than 9. First thing first, let's subtract the 3 from both sides. So minus 3, minus 3. So now we have negative 4x minus 5, the absolute value of that, is less than 6. And remember, when it's less than, it turns into an AND inequality. So we have to say negative 4x minus 5 needs to be greater than negative 6, and then negative 4x minus 5 needs to be smaller than positive 6. It needs to be between those two numbers. Move them up here. We could add 5 to both sides. And that would give me negative 4x is greater than negative 1. We have negative 4x is less than positive 11. So if you write this as a compound inequality, we would say negative 1, which is the smallest, is less than negative 4x, which is less than 11. Here's where we have to divide by negative 4, though. And remember what happens when we divide by negative x? We have to flip everything around. So we would have 0.25 from this division. That's greater than x, which is greater than 11 divided by negative 4, which would be negative 2.75. So here's our compound inequality from this. So if we create our number line here, we would have an open circle at 0.25, and it would be going this way. We would have an open circle at negative 2.75 and be going that way. And our solution would be anywhere between these two open circles. Let's look at a real-world situation then. You are buying a new computer and find 10 models in a store advertisement. The prices are $890, $750, $650, $370, $660, $670, $450, $650, $725, and $825. First we need to find the mean, or the average, of the computer prices. So we got to add them all together and divide by 10. So 890 plus 750. So I got 6,640, and I divide by 10, $664. So it says write and solve an inequality with an absolute deviation of at most $100 from the mean. Which prices fall within this absolute deviation? Absolute deviation means how far can it deviate or be from 664. So at most of $100. So you can't spend $100 more and you can't spend $100 less. So if I write this as an inequality, the difference between x and 664, which is a subtraction problem, so there's a absolute value there. The absolute value of that has to be less than or equal to 100. So this is a less than or equal to one, which would be an AND. So therefore, negative 100 is less than x minus 664, which is less than positive 100. We could add 664 to both sides then. So negative 100 plus 664 would be 564. 564 is less than x, which is less than 100 plus 664 would be 764. And here would be my inequality. I could spend anywhere between 564, and that would be less than or equal to here for being precise, which is less than or equal to 764. So if the price of the computer is anywhere within this range, I can buy it. So without typing them out, I'm going to list which ones would fall under that deviation. So the 890 would not, because it's not within those two ranges. The 750 would, as would the 650. The 370 is too cheap. The 660 is there. 670 is okay. The 450 is not okay. The 650 is, the 725 is, but not the 825. So I've narrowed my search down to 6 computers that fall within that absolute deviation.